All right, and so if we go ahead and make the calculation, let's assume the box has a weight of 100 newtons. That'll make the math easy. All right, so in doing this, we find that the weight is equal to the x component of the weight is equal to about 87 newtons. Now, you, if you want, can pause the video and give that a try on your own. All right, now let's go over and try the same thing with this being a 30-degree angle. All right, so let's say this is 30. If that's 30, there's our weight vector, then that's 60, and we want the x component of the weight vector there. So that is going to be, that's 60 in there. So that's going to be cosine 60 is equal to the x component over the weight itself. And if you carry this out, you get 50. So 50 newtons equals the x component of the weight for when the ramp is 30 degrees. All right, so what that tells us is that the x component is smaller at 30 than at 60. That makes sense because gravity is pulling more straight down, and therefore more of the x component along the plane should be at the 60-degree angle. All right, so now let's go ahead and figure out work for each one of these cases. So here's the 30-degree ramp. Okay, 30-degree ramp. All right, so this is the work is going to be the force at the 30 degrees is going to be 50 newtons times the cosine theta, and theta is 0 degrees, times the distance over which it needs to move it is 4 meters, and that comes out to 200 joules. On the 60-degree ramp, however, work equals, here this is 86 or 87 newtons. Again, cosine 0 because it's pushing in the same direction that the box is moving. And this is 2.33. And if you do that, that comes out to 200 also, within rounding. Interestingly, if you just decide to lift the box straight up, then the work you do will be the 100 newtons that the box weighs, times again cosine 0 because you are lifting in the same direction it is moving, pushing it in the same direction it's moving, and in that case that is a 2 Newton distance, and there you get 200 joules also. And so it doesn't seem to matter on a frictionless ramp which angle ramp you use if what you want to do is minimize your work. The work is the same in all cases. Now, that doesn't mean it doesn't matter what ramp you use, because mostly you probably don't care about how much work you do. You probably care about how much force you need to exert. And so clearly, in that case, the lower angled ramp will cause you to need to exert less force, in this case only 50 newtons of force, than a steeper ramp. And that's the reason people use ramps. Now here's one other way to look at why the work is the same in each case. The work is a transfer of energy from the person's body to the crate, and then the energies end up being stored positionally. And in each case, as long as there's no energy stored thermally, each case the thing is 2 meters high. And so the positionally stored energy will be equal to mgh. This is 100 newtons for that combination, and that's 2 meters. So the positionally stored energy is 200 joules. And that's true no matter how you get there. In other words, if there's no friction or air resistance, it doesn't matter what path you take to get there, the amount of work you do is the same.